Thank you very much. It's absolutely great to be here. And definitely grab the beer. You may need it, but hopefully I'll keep you interested. Let's see. So today, so just to be very open and honest, I work for a company called Sysdig. We do sell some commercial solutions. Today, I am not going to talk to you about commercial solutions at all. Falco came from Sysdig Labs several years ago. It was adopted by the CNCF in, I think, late 2018. And it's now an incubation project, which I've probably talked over my slides already. But I wanted to be very, very honest. I'm not here to sell you anything. Everything that I'm going to show you today, you can use with open source Falco. You can get up and running. We've trying to expand and grow the community always. So if you've got questions, there's a Falco channel in the Kubernetes Slack group. The community team are always willing to help out. Any questions today? I'm also on the Software Circus Slack group, so any questions for me, feel free to look me up. So let's start with what is it. So in security, you've kind of got the two sides of things. You start with, well, you've got prevention. This is the use of policies to actually change the behavior of something, so to stop something. Your typical solution here would be a firewall. You want to block certain access to certain things to stop that negative thing from happening. Within the container world here, you could be blocking certain containers from running, certain processes, you still have virtual firewalls in there as well. On the flip side to that, you've got detection. So this is monitoring all the things that you don't yet know you need a prevention policy in there for. This is kind of looking at the anomalies, things that you don't necessarily expect. This is why things like Splunk, tools like Splunk, are so widely used. Obviously, Elasticsearch and Kibana. Why so many people use that from with their Kubernetes and their cloud native solutions. You need that logging piece to keep an eye on what's going on. That doesn't mean you don't do prevention. It doesn't mean you don't do detection. Generally, you're going to need both. And both of them, they work together to kind of improve each other's overlook on things. So Falco is really a security detection side of things. Now, there's various different enforcing tools when we're talking the context of Falco. So you've got the idea of sandboxing those individual containers. There are lots of security stuff out there. Seccomp profiles, SE Linux. I won't read the full list. You can read it. I can share these slides later on again on the Slack channel as well. So don't worry too much about screenshotting, and I'm not going to read everything because there's a lot of information to take in. On the flip side to that, you've got the auditing stuff. So yes, you've got the basic Linux stuff, Audit D, the Kubernetes Audit Logs. I don't know how many people are using those, redirecting them to Elk or something to try and work out what's useful in there. And then this is where Falco comes in. So Falco is about auditing all this activity, all these events, all this information. We'll get into the details of what that looks like. So why? So runtime security, I always give this as my analogy, and it's a poor excuse to introduce my dog, because who doesn't like a nice German Shepherd? This is Jabba the Mutt. So I've got locks on my doors. I've got an alarm system. I've got cameras. But if for whatever reason, I've also got a teenage son, if he walks out in the morning and forgets to shut the door, which honestly, it happens more than I'd like to admit, I'm very happy that I've got a German Shepherd who can alert me to these sort of things. If someone is snooping around outside of the house, trust me, Jabba is going to tell us that something is going on that's not standard, that's not normal. So this is kind of what we got with Falco. You've got your security rules, you've got your firewalls, your load balancers, your security restrictions around your estates. But you still want to check that you want a Jabba, you want a German Shepherd prowling around, keeping an eye on things, seeing, okay, should that be happening? Is that normal? Is that not normal? My German Shepherd isn't particularly tuned. She barks at squirrels, which are perfectly fine, but she'd also bark at people. So she definitely gives me alert fatigue. So I will send her to tomorrow's talk. So when we talk about Falco, where Falco comes from is monitoring and analyzing system calls. So what are system calls? I think we need to introduce that. The system call, to use the man page to quote here, the system call is the fundamental interface between an application and the Linux kernel. So everything you do, whether it's a command line activity, whether it's networking, whether it's writing to disk, all this stuff represents itself as a system call. Why system calls? Why are they so interesting? Firstly, it allows us to do really, really nice instrumentation. So we go in underneath everything. We kind of plug into the kernel. And then because we're plugged into the kernel as a security solution, you see everything. You're not looking at sidecar containers or injecting things into containers with things like LD preload. You're just making sure that's always available at the kernel level. And this is where the really interesting stuff happens. So we can start detecting, okay, this particular, I mean, if we're talking a Kubernetes world or a container world, and I'll talk a lot about Kubernetes and containers today, but you can do this outside of a Kubernetes environment. The demo I'll hopefully give later on actually is not containerized at all. There's a containerized workload, but what I'm monitoring is not containerized. The nice thing about containers is they allow you to profile it relatively easily. So if I've got a container that's calling itself a MySQL database and it starts running Python scripts, that's not normal. That's something that I want to be able to detect. Very easy to detect with analyzing the system calls, because I see the Python process. I might see access certain files of the file system that's not under varlib MySQL. Maybe I see it making outbound network connections, which again, MySQL shouldn't do. So you've got these nice indicators of what good or bad looks like, and you can really profile those applications. Within the open source community, there is a large number of rules that Falco comes with out of the box. Again, hopefully I'll get a chance to show you those in the demo. I've not tuned the what I'm going to demo to you, so everything that comes out, all the output that comes out later is out of the box rules and so on. So I just wanted to cover the system call piece, because I think that's important, introducing what system calls are and how this operates. This makes the Falco system really quite powerful from that detection engine perspective. So two different ways this can work. You've got system calls that come from the Falco kernel module. This is an open source developed, so yes, you are injecting something into the kernel, but it's fully open source. You can go and pull it apart. Lots of large organizations are running this. You can go and have a look at, go to the Falco Security GitHub pages, and you've got contributors and you've got users. So you can see the sort of organizations that are already trusting this. If you're not, I mean, I'm not confident to read a kernel module to work out what it's doing. Maybe you can pull that apart yourself. If you're not, you can have a look at who else is using it and have some faith that the CNCF has adopted this with some good intentions. The kernel module helps us bridge the gap between the kernel space, where these system calls are happening, and user space, where we can actually do something actionable in there. You don't want to bake too much into the kernel space, because you start making that kernel space unstable. The last thing you want to be doing is crashing kernel modules, and certainly crashing the kernel. So we're pushing this system call information up. This ring buffer is a way of constantly monitoring and filtering this system call information, so we can start working out, using libscap and libinspect to work out what system calls are important. We're not monitoring every single system call, because it would be just way too much. There is a list, again, you can see it from the documentation. There's a list of the system calls that are important. Most of it are ones that kind of make sense. So what processes are running, what files are being accessed, what network connections are being made. There are some lower level ones in there as well. We do this because kernel space is also relatively limited. We don't want to overload that. We don't want to use a ton of memory. We don't want to make it unstable. So we push a lot of stuff into user space, so you can start manipulating that and creating the rules around it. The other way to do this is with eBPF. If you're not familiar with eBPF, it is the extended Berkeley packet filter. It came from the networking world, but nowadays is very much not a networking tool, although it has some networking plays. Coleco, a few others use eBPF within their networking stack for Kubernetes. I forget the name. I think Brendan Burns did a big talk around, does a lot of stuff around eBPF as well. Widely used for observability. We've also fed back into the eBPF open source community to get some additional information in here, so we can use it to monitor syscall information. This is really useful when you've got a kind of an immutable OS, something that you can't install a kernel module in. At the Software Circus Fest, I did a talk with Andy Randall from Kinvolk, and I did this demo based on Flatcard Linux. So a mutable OS where you can't make modifications to it. Google's Cause is another example of that. So this is great, and then you're leveraging again this open source powered virtual machine. Not in a VMware sense, almost in a Java sense. It's a very, very lightweight virtual machine that goes into the kernel. It's kernel safe. It's been tested for that, so it shouldn't be crashing the kernel, so long as there's no bugs in the kernel itself, which we have found a few. So this gives you, again, a kind of the options on how to leverage this and how to pull data from here. The other data source that we have into this is Kubernetes Audit Logs. So this isn't just about system calls. This can also be about the audit log side of things. So we'll ingest the Kubernetes Audit Logs into Falco, and then you can start making decisions. So similar to system calls, the Kubernetes Audit Log, so the Kube API is the interface for every single interaction with etcd. Every single thing you do with Kubernetes has to go via the Kube API. So the Kube API audit logs is going to give us all this information. You're trying to create a deployment. You're created a new config map. You've created a new user. You've deleted the deployment. All of this stuff is information that we can then ingest and start making rules, start filtering for anomalies and doing some detection on that. Some common use cases here are things like I'm creating an ingress controller that doesn't have TLS enabled. I'm creating a new admin-based cluster role. Maybe I've got a config map that's got some plain text secrets in there. So again, you can use that same familiar, what will become familiar, Falco rules language, rules engine to start create the rules and policies to map against the Kubernetes, again, anomalous activity within Kubernetes itself. Once again, lots of rules come from the community, so you can get up and running fairly straightforward without having to learn the Falco language. And a diagram of how that works. I kind of explained this already, so making it nice and simple. So once you've got Kubernetes audit logs enabled, you push them to the Falco web service, and then the same process starts to be able to ingest those and use them for the rules filtering. This is what the overall architecture looks like. So you have what I've been talking about so far is the kernel probe or eBPF module, the Kubernetes audit events. This comes into the event feed. From here, we have our filter expression, which is where the Falco rules kind of get plugged into to start working out which of these events would trigger a particular rule. We have a kind of a fast path for matching those rules. So we're not going through the entire Falco rule list for every single event that happens. We have a way of rapidly searching through that list, just so we're not creating too much work for the Falco engine to do to make a decision on is this good or bad behavior. Based on that, then an event is generated or alerting event. Various ways you can push this information out. So for what you'll see me demoing today is pushing this out via syslog output or standout. You can also push this to a file. One of the things we've been, one of the things the community has helped us out with is releasing the ability to push this out via HTTPS and gRPC, so you can have much more programmatic access to the events. This is what then introduces the Falco Sidekick, which I'll cover in a sec, and the Falco Go client, so you can actually have a programmatic interface to the output that comes from this. And I'll talk more about the actions in a second as well. But just to recap, the Falco engine, all it's doing is generating the events. It's just telling you that something happened. If you want to do something about that, that's when you then need to kick in your workflows using something like the Falco Sidekick, the Falco Go client. Otherwise, you're just going to be logging this, hopefully sending it to something like Elk or Splunk or whatever tool you want to use for your log aggregator. The Falco rules are written in YAML. What isn't these days? So long as you get your indentation correct, they're fairly straightforward to run. The Falco, the rules file supports macros and lists, and then you've got rules. This makes it quite kind of simple from a programmatic point of view. You create simple macros like identifying a container, and then you can reference this macro across all of your rules. So if at any point what defines a container changes, you can just change this particular policy here. Lists as well. We use some of our customers, some of the Falco users leverage lists for things like here's a list of trusted IP addresses, or here's a list of known or unknown untrusted IP addresses. You can dynamically write those and add them into the system as well. So lots of power into this. There are multiple ways of installing Falco. This is covered on the website. I'm not going to go through all of these. Of course, as a security product, we have a curl sudo bash commands. These 3 exclamation marks take you to a website, take you to a blog post that tells you why this is a really bad idea. Please download the install script, check it first, then run it. but if you really, really trust us, which you shouldn't, don't trust anyone basically, then you can run this command and get quickly up and running. And again, within Kubernetes, you can deploy this as a as a Helm chart or as a daemon set. I think we've also got some documentation of running this in kind, as well as mine's gone blank. Sorry. Yeah. Anyway, there's other ways of doing it. Sorry, my mind's gone completely blank. What else I was the other example I was going to give there? I should have written some more notes. So let me quickly throw across my screen here. And so we just clear that screen. So what I've got at the top here is I'm just looking at the output from Falco. So this is obviously I was doing a little bit of testing before. And then down the bottom screen here, what I've got is a I am running this, so I've got Medulla Aquila's hacker container. It's got a whole bunch of tools built into it. It's really, really useful if you're kind of messing around or doing some pen testing or just doing some red team, blue teaming type activities. Lots of built-in tools. What I'm just going to use is a tool called Linus. I need to get I wrote these down and then my window disappeared on me. So there we go. That's audit system. All this is going to do is, as you expect, is going to do an audit of the system. So it's going to check if it can access certain things, and you'll straight away see some logging activity happening in the top window. So what's happening here is that we're detecting certain activity. We can see network tools being launched. We can see, I'm going to crash that, and then we can use this to scroll up a little bit. So we can see, yeah, most of that activity actually. Whoops. So here we can see sensitive file data has been opened. Like I said before, sorry, I should have said this, repeating myself, but this is using the default rule set. So I've not customized anything here. This is just what's being checked for out of the box. We can see that tool was checking etc shadow files. It was launching some network tools. We should be able to see the details of what that was. My camera's in the way, so I can't see behind that, but we can see the details of the different activity within this. So yeah, so you can see all the different activity here going on. I'm just going to come out on that. Whoops, wrong hotkey. So the other thing we've got that comes out of the box that we have within the open source community is if you want to test everything, I think I just did the wrong one. No, that's right. So we have an event generator, and this is going to create lots of activity, which you'll see as it kicks off in a second. And you can see some of this activity being marked in obviously critical. So we're seeing rights below binary directories. We can see changing user IDs. Again, I'm going to kill that off so we can have a look at these. Changing set UID PID. Scroll up through these. So you can see the sort of activity we're looking for here. It really is kind of quite a wide array of different activity we're searching for, looking at things that are typically quite anomalous activity for a container to be doing. In this particular scenario, I've not got Kubernetes running here. Actually, I'm not running other than the container that's generating the anomalous activity. This is actually just running Falco as a base Linux service. So you could run these, although we've got checks here that are specific to containers, you could also run this against different activities to check for, is my Apache web server just doing Apache stuff? Am I getting writes to anywhere outside of, or am I getting people writing to var www.html, for example? So very, very powerful from that language perspective. And then switching back to the slides. Actually, one sec. I wonder. No, I'll go back to the slides. If I've got time a little bit later, I'll cover what the rules file looks like. We kind of touched on that a little bit earlier, but there are a lot of rules that come with it, so I won't overwhelm you. There are various additional integrations to the Falco platform. So in terms of the installation, you've got the Falco operator. You've also got Falco CTL, Falco Cuddle, to kind of interact directly with Falco. The Falco Sidekick is probably the one that I definitely would recommend. I'll touch on that in a second, but it's a great way of taking that output and giving you much more actions on what to do with that output. Various other things, the response engine also I'll talk about. So again, taking that feedback out, taking the output and doing something with it. The community also created a great Prometheus exporter. So the events that are being generated are happening. You can start creating Prometheus metrics for this, and you can start charting that out. I've got some slides that show a couple of the integrations there. So firstly, what the Sidekick is. So the Falco Sidekick runs, if you're running this in a Kubernetes environment, the Sidekick runs as a sidecar to Falco. It takes that output from that we saw being generated there, that event feed, and enables you to port that into much wider set of different applications. So I won't read the list, but you can see the different uses here. So you can start creating kind of an alert system, push this into various different monitoring tools, or even put it into your own workflow, put it in something like SQS or NATS to then create a workflow where you're picking up from that pub sub hub and actually making some actions from that, which I'll show you in a sec. So if you're looking at extending what the events are happening, you don't just want an event feed, the Falco Sidekick is definitely where to go to look into that. So having a look at what the response engine and the Falco Sidekick looks like. So like I say, they will run as a sidecar container. Sorry, the Falco Sidekick will run as a sidecar container. Publish that to various different things. Let's assume we're publishing this to a pub sub hub engine like Amazon SQS or NATS, CNCF's NATS. From here, we can then, the response engine can pick up on that activity and do some sort of action. So now we can say, okay, my MySQL server is suddenly running the Postgres process. I'm going to kick off a workflow that will kill that container. Or if I've got a RabbitMQ server that starts making outbound network connections, again, go in and kill that particular container. You can do other workflows. We've had some other demos in the past from the community where based on a certain workflow, what we do is we change the load balancer algorithm. So if a certain web server starts producing anomalous activity, we start redirecting traffic away from that particular web server, so we can effectively isolate it out. Various different workflows you can play. That's just a couple of examples that we've seen and we've written up on here as well. So there's other ways of doing this. So this is kind of before we had the sidecar, the Sidekick. You can also, there's also a NATS sidecar. So this is publishes directly to NATS, and then again use the response engine to, very much like what I said there. By putting it into something like NATS, you can use the same message repeatedly. So here what we're doing is we're both putting that message across to Kubernetes response engine to take some sort of action. We're also feeding that across into Splunk here into Phantom. So you've got the log of those activities as well. You can, when you publish these different events, you can publish them to different topics. So you might publish them with different severities. So only certain severities would get actioned by the response engine. You certainly don't want to be killing all the containers all the time just because a certain rule is being triggered all the time, but you probably do want to be logging that all the time. So that's one of the advantages of putting it into a pub sub hub engine, because then you can start classifying those different messages according to their severity or according to other metadata that exists in there. As you saw from, as you may have saw, oops, get my terminal across here. There's a lot of additional metadata around this. We can see what container it existed in. We can see what the different parent processes are. There's a lot of information here you can use for setting up the different intelligence in there in terms of where you want to route that through. You could also put severity messages on there, which is why some of those outputs were marked in red. They were obviously being classified as high severity. An example playbook, almost identical to the last two, but here just using native Amazon services and then pushing out to Slack. So you can do exactly the same thing with some of those native services here as well. And then a sim, I tried to get it set up for you to actually demo it, but unfortunately I completely failed. Ran out of time today with work getting in the way. We've got some screenshots from it, so I will walk this through this. But this is the idea of I kind of touched on this, but taking that event information from Falco, feeding it into some sort of SIM platform, this particular scenario using Elasticsearch, Fluentd, and Kibana. Obviously, it can be any number of SIM platforms. If you're using Splunk, if you're using Logzio, if you're using LogDNA, it doesn't really matter. The mechanism of getting information in there is fairly straightforward. Within Falco, generally, you're going to do this in one of two ways. You're going to log that event to syslog, which is probably going to be shipped off to a log server somewhere anyway, and then filter that events away from standard syslog messages somewhere else. The other way of doing it is tell Falco to log to a specific file and then treat that file separately. That might be a little bit more powerful in terms of figuring out exactly what to do with those, because they're going to have a slightly different formats to just standard syslog messages. From there, you can start visualizing things, which we've got here. So you can start visualizing how often different rules are being triggered. This is part of the metadata that gets posted in the event. So you can start creating kind of some threat analysis, work out what the top things people are doing. This isn't always just from a kind of an external threat perspective. Sometimes this can be really useful from an internal development perspective and just an education perspective. If you see that people are constantly SSHing or kubectl exec into your containers, you can kind of pick up the phone to them and say, that's not really what we should do with containers. That's not how we should be developing with containers. Containers should be treated as complete black boxes and ephemeral. So you can maybe start some education there. Someone's running a container that's running a whole bunch, they've got a MySQL server, and then they run a bunch of Python scripts on that MySQL server to do some maintenance. And again, you can do some education there to introduce the concept of sidecars, or maybe just have Kubernetes jobs, whatever that looks like, to improve the way you're working with containers, the way you're working with microservices in general. So I find this can be really useful just purely from that educational perspective. Various resources, various links in this. Like I say, I will share this in the Slack group. I'll pass it over to Sam and the Container Solutions team to share with, if there's other ports to share these slides. There's various other talks. Some of our open source team, some of the open source team for Falco also literally wrote the book on BPF. And there's lots of recordings and other resources in terms of better demos than I've delivered. So if you have had a beer, I hope it's now empty. And that's it. So that's a little bit quick, but I think gives you a little bit more time. Any questions at all, feel free to ask them now, or like I say, I am on Slack as well.
Thank you very much, Chris. Great talk indeed. Good luck, very good performance. Really appreciated it.
Nice.
Does anyone have questions for Chris? We already have one in the chat for Herman, from Herman, who asks if you could run Falco locally with that enterprise license / support. If it was mentioned, he might have missed it.
Yeah, no, yeah, apologies. That was right at the start. I kind of gave my caveats that I work from a commercial vendor. Falco is fully open source. Everything I showed you today is fully open source. If you want support and license for it, yeah, feel free to speak to me and we can talk more about Sysdig. So Sysdig is the commercial entity. Falco is a CNCF project. It is fully open source. Everything I've demoed today is available. There was a Splunk logo in there, and obviously that's not free, but everything else I showed today and demoed, again, is all open source. So yes, you can absolutely get up and running with that.
Thanks, Chris. I hope it answers your question, Herman. Anyone else has a question for Chris?
So I think the filters you showed focus on the runtime security risks of your
Yes.
Is there something in the plans, or is there some functionality like a webhook admission control, like a webhook, an admission webhook for?
Yeah, so we've been talking a lot, the different communities have been talking a lot around how we can use Falco and OPA together. There's no point in Falco writing an admission controller. A very good one already exists. The OPA framework is really, really solid. If you've not logged into OPA, please do. But we're looking at ways of, because effectively with Falco, and there's some Sysdig open source components that do something similar as well. So again, nothing commercial. What you can do is you can effectively profile those system calls and create You can't do it yet, but in theory, by profiling those system calls, you could create an OPA gatekeeper policy that would then say, okay, if you're spinning up this particular workload, you've told it to do something that it shouldn't do. So I know right now, no, but I know the teams are looking into that. If you've got some ideas, love them to be shared in the community as well.